Good morning. My name's Stephen Carl-Henny. I'm Managing Director and Founder of TISICS Limited, and I'll talk you through what TISICS technology to deliver net zero is. So, aircraft today are losing weight to reduce emissions. So 50% of them are polymer composite. That leaves 50% which aren't polymer composites and largely metallic. What can be done to improve the metallic parts on aircraft to make them lighter, make them more efficient, reduce the amount of fuel burn? So we're focusing on landing gear, heavy metallic parts, take the mass out of that, we can really reduce emissions, engine components, and other metallic parts such as the wing components. So this little tube here weighs about the same as a packet of chips, but will carry 5 metric tons. That's the same as an Indian elephant. Very, very strong in compression, very light. Come and see me later if you want to see just how good that is. That equates to 9 million tons of CO2 reduction across the aircraft fleet if we did landing gear alone. And significant reduction in fuel consumption, which means airline costs come down. So, earlier this year, we made an A330 twin-aisle side stay. There's one on our stand. Come see us on F155 stand, fitted it to an aircraft, but also tested it. It failed at 620 tons. That's 50% higher than steel part fails at, exactly where we expected it. It will save on each aircraft 760,000 euros of fuel a year. It's 13% more cost effective than swapping it just for titanium. So a huge benefit to airlines and to the constructors. So what's our plan? We're taking TISICS to start with landing gear, develop the technology for landing gear and get that in production, carry on to wing components. We're working on aluminium tanks for liquid hydrogen, next but one generation fuels, and engine components. And in the future, using struts like this to build blended wing aircraft, which will be a truss structure aircraft with a composite cladding. We've got a vertically integrated capability. We can do most of the technology from the fiber all the way through to manufacturing parts in-house. We've recently bought 2 technologies. We have a pre-cap investment of about 1.3 million euros and partnerships with most of the major aerospace companies in Europe. We're seeking 3.5 million euros to grow the technology, to qualify the technology and get this technology flying within the next 3 years. And that will allow us to build to around a Series B funding to build a next generation factory so that we can scale to much larger components, larger number of components, and extend beyond the aerospace sector. How do we fit within the ecosystem of materials? If you look at similar material companies where they sit today as advanced material suppliers, that's where we will be in 3 to 5 years' time. Exit routes, either sale to a tier 1 supplier or partnership, out to a material supplier because this is a core material for multiple applications, or a joint venture and licensing deal with our customers and our supply chain partners. Thank you very much. If you've got any questions, let me have them. And if you can, come and see us on our stand, see some of the real size parts and see what we're actually doing. Thank you.